the reason that we need to use exception is to cover all unexpected errors that may occur in the future, as when the computer your system, your coding is executed. More sophisticated programming languages provide more functionalities about exception handlings. Python does a little bit, but not as much as other languages. Other languages means more technically a lot more formalized, a lot more saturated the languages like C or Java. Python is very, very dynamic language. So eventually this program will have that as well. Almost all the exception handling in other languages, same thing here in Java, the Python. So exceptions are provided by the language itself. I call that the interpreter here in our Python language case. If it is a Java, then Java virtual machine itself gives us the built-in exceptions. The more sophisticated the language is, the more built-in exceptions that we can enjoy to use. Python, therefore, does not provide as many exceptions as other languages can handle. And also, other languages may be able to do the control the external devices, and also within the same platform, not only running on the application layer, but also deeper layer, so that kernel level of system calls may be allowed to call in your application languages. Therefore, more exceptions needs to be, that had been developed. So those are the built-in exceptions. But as we develop the computer systems is the software systems, then we may encounter more business logic specific exceptions may take place. One of a simple example is if you see the user interactive the coding, so using input the function, you may ask to user if that is a computer employees database to be built. Therefore, you may ask user employees, enter your, for example, your date of birth. Then simply the built-in exceptions may need to check if that is a real date, right? So date type may be handled as an exception that is already expected by the Python, for example. But if you want to see some business specific the situation, then if it is an employee, then if someone wants to enter the date of birth, for example, 1919, year 1919, month maybe December 31st. Okay, 1919, December 31st to 1919. If that is date of birth, then that person probably over 100, right? Then less likely to be employed, right? So that's a business specific situation, and that maybe it's not really data type wise error, but logic wise error. That type of things needs to be developed. So exceptions needs to be pretty much defined by a programmer or a coder. This is a secure and intelligent the programming course, right? We don't do much about, real the coding itself. I want to give you some of the ideas. So, what you can see from this slide, to handle any situations that have not or cannot be generally expected. Generally expected means not generally expected by the language itself. Specific exceptions needs to be handled. So more exceptions are needed. So if we agree with the exceptions, and if we need to handle that exception, then we need to define the exception. That is a brand new exception, right? As I said, almost all the sophisticated the programming languages provide the exceptions. In part, built in already. In part, allow you to define. And exceptions are hierarchically organized. So we call that hierarchy of exceptions. Why hierarchy? But in fact, the language that we are using, like C, Java, Python, they are all object-oriented programming languages. So all the classes are organized very nicely within that virtual memory. Virtual memory is the language is handled. Some of the memory region that is handled by Python. Okay, so that is a small world. In that world, when Python runs, then all the classes already defined, all the exceptions already defined are hierarchically organized. Someone may say, hey, what do you mean by the already defined class? We use already, the classes already defined by Python. For example, if we say list, if we say, for example, dictionary, those are all already exist. Some of the types integer. Some of it's almost all the language itself is already defined in object-oriented paradigm. So they are somewhere in that virtual memory. So if we develop exception, then our exceptions should be developed based upon the exceptions already organized. So your exception needs to be plugged into somewhere there. So it is called the specialization. Top of the exceptions, there is, I think that is maybe some of the, that exception covers everything about the exceptions. I believe that is called the base exception. And on the base exception, we have some other kinds of exceptions also. Let me see if we have that. Yeah, this slide, and also this is in your textbook. On top, there's a base exception, and then that is really the top. And then there's a children node below that. So systemic exit exception, keyboard interrupt exception, generator exit exception, and simply exception and error. Under exception, we may have some stop iteration exception, some of the name error exceptions, and runtime error exceptions, and value error exceptions. So many of those, right? So our exception may be, if you want to develop your exception under, for example, you can design the way that if you want to put your exception one of these child, that's fine. This is my exception. And then, or if you want to do, for example, module not found error, if you want to make your own exception here, then probably why this is. So another case of recursion error, then I may have another exception. This is my exception. This is her exception. Within my exception, I have another exception, my specific exception, exception one, my specific exception two, my specific exception three, and so on and so forth. We need to define that. As we define that way, then internally in the virtual memory, my exception organized in this way. Okay, back to our slide. So this is some of the exceptions that we looked at previously. So in this case, how we can define exception? The topic that we are going to learn today is how to define, how to use. Therefore, exception needs to be handled. Okay, if exceptions, although there is an exception, but an exception is not handled, then your program will halt before it is completely terminates. It's like error. In your Pfizer execution, usually then you have some of the error messages in red color. That is the exception, right? So to avoid that exceptions, then you need to handle it. Therefore, there may be no errors. No error, first of all, important. Number two, you may, if there is some exceptions, when some exception is caught, recognized, then you can do something in response to that exception. This is an example. Define exception within a Python code. Write a Python code to create a dictionary of employees and monthly pay. Dictionary of employee and monthly pay pairs. Okay, that is a employee and monthly pay pairs for a given employee list. Assuming the range of employees' monthly pay for each employee, and monthly pay is interactively received only if a given salary is in the permitted range. Employee and salary pairs can be stored in a dictionary. I think this is the main code. Okay, from here there. So let's look at. This is employee A, B, C, D, E, okay? And monthly pay is a dictionary. So dictionary is called this month pay. So each month we may have different pay. For I in range len employees. So we have one for each of these. So this guy will gives you if this is length 1, 2, 3, 4, 5, then this is nothing but range 5 because the length is 5, right? For I in range 5 and employee, this is an employee list. From there, so I starting from 0, so 0, 1, 2, 3. So 0, for example, first one is called employee. So employee name is A, and we can say prompt, enter the pay here. This is the input and prompt. Enter the pay for employee, whoever that name is. We can say, enter the pay for employee A for this month. Then user may enter some value. But remember that this input function takes the string from the keyboard. So user enter the keyboard, right? The keyboard, the character entered from the keyboard. Probably that is the pay. So that is a number. So it can be converted to integer. So monthly pay will be an integer. We assume this also. If you do not trust user input, then you need to verify if this prompt is really integer like a string. Someone may enter if you do not, your code do not restrict to choose the keyboard. Okay, then it may enter anything. So enter the pay for somebody is for this month. Then someone may say excellence. Then excellence is not a number, right? That should be sanitized. But forget about that this time. Let's assume user gives the integer. Integer that is not really integer if it is on keyboard. The keyboard, there's 1, 2, 3, 4, 5, the keyboard on top, right? And then there is another, the characters, Q, W, E, R, T, Y. There's also characters, right? The keyboard on the keyboard, the keys on the keyboard, for example, key, character Q and key number 1, they're the same key, right? It's not really, when you press number 1, it is an integer. When you press number Q, that is a character. It's not like that. Anything that you press on the keyboard, that is all string. So that should be converted to integer. So that is a month pay. So far, we trust the user. Something that we need to do more is here. Monthly pay, if monthly pay is less than 1,000, then we need to, this is some exceptions in our business logic, okay? There is another, so business logic, in this specific case, anyone in our company needs to receive at least $1,000 per month and at most $9,000. If it is over 9,000, if it is below 1,000, then that is an exception. So we take care of that. And this is the legal ones. And anything else, we raise another. Pay range, the upper bound is $9,000. This is another. So you need to highlight the yellow here. So what happens here is that we need to raise the word raise. This is a reserved word. Using that raise, we raise exception. So pay range is nothing but exception. So pay range needs to be defined before we use this. By the way, up here, we already defined it. Class pay range. This is pay range. Pay range, this is class, but class is nothing but everything is class if it is object-oriented language. So pay range is a class, but this is a subclass of base exception. Pay range is a subclass of base exception. What it means is that pay range is defined here. So we have a pay range. Pay range will sit on here, this place in this hierarchy. As far as I said, class defined, class pay range defined based upon base exception. And then we didn't do anything here in this case. You can implement it inside here, right? But we didn't do that. That is basically what we need to do. All right. But if you see this base exception, then there is a some of the error messages can be taken. So whatever this message will be taken by this pay range. We have that. So this range needs to be within try block. So everything from there to here, there is a try block. If we try, then we have except block. So try and except. On this except block, because we already raised the exception, we need to take care of the raised exceptions. Raised exception here, only one exception. Same exception raised twice. Anyway, we can handle it. We can say pay range as E, print E, then whatever this class is, that class is printed. And then finally, if that is a regular payment for month, then it'll be printed here. Okay. I think we need to practice this. We can practice this a little later. Let's okay, I think I need to go back. But this is a better, because the previous we have only one exception. So multiple exceptions, multiple user-defined exceptions. So we can practice this. If you see here, this code, above all this, so we define three exceptions as classes. And then this, if we don't have exception definition within a class, then our code usually starts from here. This is our code. Except error true, this simply Boolean variable, true or false, but we say true. Employee name is given by user. And while EXP error, which means EXP error is nothing but true. So while true. So because if this condition is true, then while loop continues. Somewhere inside, we need to say except error is false, like this, right? In this case, then there's a termination of this while loop. So this entire is while loop from here all the way. In this while loop, we have a try and true except. So try, except. So we define the probably true exceptions. Here, too little experience, too much experience. So too little experience is based upon the exception error, okay? And too much exception is based upon exception error. But this error is also defined, which is based upon base exception. When we define error, error has underscore and underscore init, underscore and underscore, self, comma, m, and then string underscore and underscore, strs, underscore, underscore, and then self. If there is an object orientation, then the class can be defined, and then the function, the default function, in this case, two default functions are defined. One function is init, and the other function is string. This init function is automatically that is initialized. When this function is initialized, when this function is instantiated, when this class is instantiated. So class is kind of a blueprint, and object is a real entity for that blueprint. Based upon this blueprint, we want to create a specific error. So one error is that is nothing but an object. As we instantiate the class, therefore create an object, then we can use this init, okay? We don't call it by init, but simply like this. This is instantiation. We simply send error messages like this or like this. Okay, those are the error messages. We define init. Once we define init on error class, this init also inherited to the subclass, too little experience or too much experience. Because too little experience and too much experience is the subclass of error. Error is also subclass of a base exception. But error has init and string function. So without having to redefine the same function for this subclass, we can still use it because these guys can be inherited. Okay. So init is a function that can be used when an object is initiated. And string is a function when this object is invoked. When an object is invoked, then what we need to do? We need to return messages. Self is if this error occurs from a specific object, then that object, message of that object. Because this is a blueprint, there may be multiple objects generated. So at each point, object one has a message. Object two may have different messages. That message is nothing but self.message here, which is assigned from this initialized, when this function is called, message is entered, okay? Like this. So without having to specifically using this function signature, because this is a magic function, so-called magic functions. It's not the function that we typically use. This is a function defined in a class so that we have underscore and underscore, function name and underscore, double underscores before and after. Init and string, there's a reserved function. Init function is activated when an object is created. STL function is activated when an object is invoked. Okay. So here in except block, when you come here except block, this is the exception as E. This is a specific object. Then we print E. Simply, I want to print an object. So whatever object that is, there could be too little experience. Then object for too little experience, then we can get this too little here. This is messaging. Raised when year experience is less than 2. Raised when year of exception is more than 33. So that is a too much experience case. This is a too little experience case. Based upon, for example, in this try block, if experience is less than 2, then we raise exception. If experience is greater than 33 years, then we can say too much experience. Anything in between these 2 and 33, then we can say, employee, you are qualified applicant with whatever that is. Okay. So this is this will continue as you enter your name and enter here input. So your name is used here, right? Hey, Mr. Yoon, enter the years of your experience. Then we can enter something that, depending upon the experience year, there may be some exception handles, or that the loop terminates. Okay. In this case, else case, we say, oh, you are qualified applicant, and then this condition, exp error, is turned to false, therefore while loop terminates. Okay, so I want to discard this. Okay. New is too small. Oh yeah, we can do zooming control. Yes, so I can do control. Zooming control. Control. Okay, so this is so much. So we can say this is the exception, but user-defined exception. Exception. Okay, I want to copy and paste the code that we have. So, base exception, we create class error with the function init and string. Under this error, we have two specialized exceptions. So too little exception, too much exception based upon error. So error is above, and then the other two below in that hierarchy. And then this is just a message. So you don't, this is my comments, right? And then in this while loop, I have a try and to accept. Within this try block, I have the branching statements. So based upon them branch, we can raise the exceptions or the valid condition or regular cases. And if we run this, enter your name, we can say John, and then enter the year of your experience. If I say 44 years old, then it asks, it says raise when the raise occurred, the exception is raised, right? Why exception is raised? Because when the years of experience is more than 33. So too much the exceptions. There's a reason. So the while loop continues. John, enter the years of your experience. Then if I can say 1 year, then you can say another exception is raised. The exception raised here is when the years of experience is less than 2. My case is 1, therefore raised. But if I say something other than that, like 11 years, then it says, hey, John, you are a qualified applicant with the 11 years of work experience. Okay, that is something that you can have here.